All right. Good to go. Let's get going. All right. So, do you guys remember the difference between independent things and dependent things? Tell me. I see. So you're like relating like an independent variable on a graph to a dependent variable on a graph? Hey, you two might have to go to the library. So independent versus dependent. But I'm talking about like whether two situations are independent or dependent of each other. Do you remember those?
Oh, yeah. So independent means like the one happens on its own. Dependent means that something else has to happen, or yeah, it's related to something.
Related to something. That's the big deal. Yeah. I'm going to call dependent samples. You could also call these paired samples, where one is directly. Oh, are they really? Okay. All right. Go back, but just try not to be too loud. Okay. One is directly related to the other. It's a one-to-one correlation between the samples. An example of this would be like if you take like a weight loss drug, your before weight and your after weight. That's definitely paired samples. Like, it'd make no sense that if I was taking a weight loss drug and so was Mitchell, that we would compare Mitchell's before weight to my after weight. You have to be with the same person. Okay, independent samples is where a sample from one population is not related to the other. An example of that would be something like the scores of like 50 of our students on the ACT, and then the scores of 35 students on college entrance exams. The people who take the ACT aren't necessarily the people who are taking the college entrance exams. So they really can't be paired together. You know that they're definitely not because, I mean, look at this. They might have some overlap, but there's 50, right, who took the ACT and only 35 who took the college entrance exam, so you can't even match them up one-to-one. So for an independent, for a picture, it looks like this. You have two populations. This is sample A, sample B. This one, maybe you have a few samples in here, a few numbers in here in your sample. This one's sample B, maybe you have a few numbers. They do not need to be the same amount of numbers. They could be, don't have to be. But for dependent, they have to have exactly the same amount of data points because they're connected to each other. If you're doing weight testing, you have to have a before and an after for every single person. They connect 1-to-1. So the sample size on this one has to be the same. And on this one, the sample size could be the same or different. You guys feel like you understand? You could do like a paired sample dependent test, like for example, if you were trying to think of somebody's like memory retention. Because what you do is you say to somebody, okay, I'm going to tell you like 20 words, and right when I'm done, I want you to tell me back as many of those 20 words that you can remember. And then 5 minutes later, you interview that same person again and ask them to tell you the 20 words again. And then write down how many they remembered immediately and how many they remembered after 5 minutes. And then it's a paired sample, right? Because it's the same person, same data. So, all right, your turn. Tell me, is this independent or dependent? I'll give you prizes. Heights for 27 adult females, heights for 27 adult males. Who's got an idea? Megan, you're 1. Michaela, you're 2. Megan.
Independent?
Yes. Why?
Well, they're two different things, like adult females and adult males, you can't like compare them or anything,
Right.
even though they have the same sample size.
And you wouldn't have a 1-to-1. Now here's a way we could actually change this. They do have the same sample size. They're both 27. But here's a way that we could change this problem to make it dependent, okay? If I said adult of 27 mothers, and then, or heights of 27 mothers, and then heights of their 27 sons. You know what I mean? Then I could be like, okay, now let's see, is there a relationship between the height of the mom and the height of their son? But if it was just some random female and some random male, there's no reason to connect those at all. How about the next one? Michaela, you want to do this one?
So independent.
Yes, why?
Because it has, like it's the same students, same sample size.
Right, that's a big deal. When it says the same, you gotta look for that same thing. Okay, Michaela and Megan, would you like an animal or an winter sign or bounce ball?
Hold on, I want to see what this thing is on the end here.
It's a little duck, we got a ram and a goat.
The ram, interesting. I'll have an I'm a one sign.
Okay. There you go. All right, page 2. So here's the directions for doing a 2-sample independent mean test. So this is important. Notice that it is independent. Our next and population standard deviation is known. Okay. So first step is that you need to verify all the things. So verify that population standard deviation is known. You also need to verify that they're independent. And they're normal, or both of the ends are bigger than or equal to 30. What do you think I mean when I say both of the ends? Right, we're comparing 2 different populations this time. I don't think I wrote all of the notes for this. Mail, credit card debt, let's see. There we go. Okay, so we're gonna work the problem and the example at the same time, so I'm gonna go down to the problem. Step 1, population standard deviation is known. Do you see how we have sigma 1 and sigma 2 for California and Illinois? That means we know them. And in fact, I'm actually just gonna start setting up my stuff here. So we got California, we got Illinois. This is the stuff that I didn't mention to you, so I should have not mentioned to you, but I just didn't write it down on this paper.